Hey everyone, and welcome to this explainer. I am absolutely thrilled to guide you through today's topic because honestly, we are looking at one of the most dynamic, active, and frankly stunning objects in our local universe. Our focal point today is NGC 6946. It's a spectacular, explosive spiral galaxy that is going to completely change the way you think about galactic structure, magnetic fields, and cosmic forces. So get ready, because we are diving deep into a galaxy that is literally bursting with activity. You know, astronomers don't just hand out cool nicknames for no reason. This galaxy has earned the highly appropriate and awesome title of the Fireworks Galaxy. Why? Well, in just the last century, astronomers have observed a staggering, record-breaking 10 supernovae going off within it. 10. I mean, to put that into perspective, most galaxies, like our very own Milky Way, might see 1 or 2 a century if they're lucky. This incredible rate of explosive star deaths makes it a true cosmic spectacle and a perfect laboratory for understanding extreme galactic physics. All right, here's our game plan for today. First, we'll meet the Fireworks Galaxy. Second, we'll explore the galactic gas engine. Third, we'll look at its magnetic arms and anomalies. And fourth, we'll discuss the role of electric currents. Okay, let's jump right into part 1. Meet the Fireworks Galaxy, a true cosmic spectacle. So, the crucial starting point is understanding exactly what and where this galaxy is. The Fireworks Galaxy, which is also known as ARP-29, sits roughly 25 million light-years away from us, resting right on the border of the Cepheus and Cygnus constellations. As I mentioned, it holds a galactic record with 10 observed supernova, putting it literally at the very top of the list for nearby galaxy disks. Structurally, it's classified as a non-grand design or multi-arm spiral galaxy. Basically, that means instead of just 2 perfectly symmetrical, neat little arms, it has a much more complex, sprawling, and branching structure. Take a look at this H-alpha map. Notice how far out that spiral structure extends? We are seeing signs of massive star formation happening way beyond what we traditionally consider the edge of the optical disk, stretching all the way out to 1.3 to 1.4 R25. It tells us that this galaxy isn't just active right in its core, the whole thing is practically bursting with energy and newborn stars all the way out to its absolute fringes. Moving right along to part 2, the galactic gas engine. Let's see what's fueling the fire. So ARP-29 features an incredible internal plumbing system. It is one of the nearest large double-barred spiral galaxies. Think of these bars as a massive gas-assisted conveyor belt. First, you have this large-scale stellar bar, spanning roughly 3.7 to 4.5 kiloparsecs, which is responsible for building up mass in the central region. But nestled right inside that is a small-scale inner bar, only about 400 parsecs across. This secondary, smaller bar acts like a final funnel. It takes molecular gas, which is the vital fuel for star formation, and drives it directly into the galactic nucleus at incredibly high speeds. It is a highly efficient engine for feeding these nuclear starbursts. But what happens after those stars form and eventually explode? Well, they leave a massive mark. The galaxy's hydrogen gas disk is completely riddled with giant voids, sometimes called superbubbles or HI holes. And these aren't tiny little pockets. Some of these holes are up to 2 kiloparsecs wide. That is staggeringly large, reaching a size that's actually much thicker than the gas disk itself. They are essentially blasted open by the sheer force of multiple supernova explosions going off in the exact same stellar neighborhood. It really paints a vivid picture of a violent, bubbling, and just deeply dynamic interstellar medium. All right, next up is part 3, magnetic arms and anomalies. This is where we look at the invisible structure. If you look closely here at the northern arm of the galaxy, you'll see these strange, unusual red ellipses and cross lanes captured in optical and infrared. They look almost like alien artifacts, right? Researchers have actually identified these as candidates for anomalous microwave emission. And what causes them? Well, the leading theory right now is spinning dust grains in the interstellar medium, emitting radiation as they rapidly rotate. It's an incredibly peculiar feature that astronomers are still trying to fully unpack, and it highlights just how wild the environment in this galaxy really is. Now, to really map the invisible forces at play here, astronomers rely on a very clever trick called Faraday dispersion. Basically, when radio waves pass through a magnetized, ionized medium, like the gas in a galaxy, they get depolarized. By measuring this effect across different wavelengths using super powerful radio telescopes, astronomers can actually recover the 3-dimensional structure of both the turbulent and coherent magnetic fields within the galaxy. It's essentially a way to map out the hidden magnetic architecture of the cosmos. And when they mapped the magnetic fields of the Fireworks Galaxy, they found something completely mind-bending. The crucial point here is that NGC 6946 has a unique feature that is unlike almost anything else we've seen. Its magnetic arms are located completely between its optical star-filled spiral arms. In most galaxies, the magnetic fields generally just track along with the visible spiral arms. But here, they are neatly tucked right into the gaps. It's a profound structural anomaly, and it really challenges our fundamental understanding of how galactic magnetic fields grow and evolve. Which brings us perfectly to our fourth and final section, the role of electric currents, the power source. While traditional models often attribute galactic magnetic fields to the turbulent mixing of conducting fluids, essentially a fluid dynamo, some researchers argue we need to look directly at fundamental electromagnetism. Based on Maxwell and Faraday's laws, magnetic fields are inextricably linked to electric currents. According to this alternative perspective, a time-varying primary cosmic current can induce a secondary current. That secondary current, in turn, creates a magnetic loop. This is known as transformer action, and it works exactly like the transformers on our power grids, just scaled up to massive galactic proportions. So, looking at this diagram, if we apply this thinking to cosmic scales, say a star or even a galactic nucleus, a massive primary current, changing in strength, can induce these swirling secondary currents all around it. Those secondary currents then generate the vast magnetic loops we observe. It's a really fascinating, objective look at how some models propose that electric charge flowing through space could act as the invisible scaffolding, shaping and driving the very magnetic fields we measure. To summarize this perspective, we can look to researchers like Donald E. Scott, who firmly states, magnetic fields are created by and moved around by electric currents, nothing else. While the fluid dynamo theory remains widely taught, this electric current perspective argues that to truly understand the enigmatic magnetic behavior we see in places like ARP 299, we simply cannot ignore the causal role of electric currents. It represents a pretty fundamental debate in astrophysics about the true origin of cosmic magnetism. And that leaves us with a lingering, provocative thought to end on. As we gaze out at the fireworks galaxy 25 million light-years away, marveling at its record-breaking supernova, its gas-guzzling bars, and its totally bizarre inter-arm magnetic fields, what is the real engine behind it all? Are vast cosmic electric currents the true invisible hands shaping these explosive anomalies? The universe is far more complex and perhaps far more electrified than we often realize. Keep questioning, keep looking up, and thank you so much for joining me for this explainer.